Alright, let's look at the homework 14.5, problem number 5. Alright, so we have a g of u, v is given here, and we want to find the partial derivative of g with respect to u, and the partial derivative of g with respect to v. Alright, so let's do that. So if you want to find the partial derivative of g with respect to u by chain rule, you would have to take the derivative of f with respect to x and multiply by dx over du, right? And plus partial derivative of f with respect to y, then multiply by dy over du. All right, then let's see. So you have this one right here. We know that f is a function of x and y, so this is going to be our x, and this is going to be our y here, right? So if you go ahead and take the derivative, so you have a partial of f with respect to x, right? Dx over du would be, right, partial of e to the u with respect to u would be e to the u, and partial of a sine of v is going to be a constant, so it's going to be 0. So you would have just e to the u, right? Plus, right, so you have partial of f with respect to y, then you have to multiply by dy over du. So here's a y. So partial of e to du with respect to u is e to the u. And again, partial of cosine of v with respect to u is 0, because cosine of v is a constant. So we got that. All right, then we want to evaluate partial of g with respect to u at 0, 0. So u is 0 and v is 0, right? So if u is 0 and v is 0, you have e to the 0 is 1, sine of 0 is 0, so you have partial of f with respect to x of 1, comma, right? E to the 0 is 1, cosine of 0 is 1, so it's 2. So you have 1, 2. Right? Then times e to the u. So e to the 0 is going to be 1 because u is 0. Right? Then f of f sub y, and it's going to be 1, 2 because it's exactly the same point. And then you have e to the u, so e to the 0 is going to be 1. Right? So we have that. All right, then if you look at the values, you can see that here, if you want partial of f with respect to x at 1, 2, so that's this guy. So we know that this is equal to 1, right? And a partial of y with respect to a partial of f with respect to y at the 1, 2, the value is 0. So this guy is actually 0, right? So we have 1 times 1 plus 0 times 1, so it's going to be 1. All right, let's check the answer first here. So we got 1 here. All right, submit for testing. All right, it came back and looks like we got the first one correctly. All right, so let's do the partial with respect to v. All right, so it's basically the same thing. So if you want to find the partial of g with respect to v, is going to be, we want to find f sub x times dx over dv plus f sub y times dy over dv, right? So this is going to be, all right, f sub x times, all right, now we are taking a derivative of x with respect to v. So e to the u derivative 0, since it's a constant. Derivative of sine of v is going to be cosine of v plus f sub y times, right, partial of e to the u with respect to v is 0, since it's a constant. Partial of cosine of v with respect to v would be negative sine of v. Right, so we got that. Then if you want to find that g sub v evaluated at 0, 0, right? then it's the same thing as before. So if you plug in u equals 0, v equals 0, so we're going to have f sub x, and it's going to be at the 1, 2 again, and multiply by cosine of v. So cosine of 0 is going to be 1 plus, right, f sub y 1, 2 multiplied by sine of 0 is actually 0, so it's multiplied by 0. Right, so in this case, second term drops out because it's multiplied by 0, and we know that the value of partial derivative of f with respect to x is going to be equal to 1, which is given here. So the answer is again 1 times 1, so it's going to be 1. All right, so let's check the answer. All right, so answer is 1, and submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.